it going, everybody? This is Ron Sparkman from OpportunityU.com, and today we have the great honor to speak with Dr. Stefanie Milam, who works in the astrochemistry laboratory at the NASA Goddard Space Flight Center in Greenbelt, Maryland, USA. I was fortunate enough to see her this past year at the Mars Society convention, where she talked about the James Webb Telescope, which is what we're going to dive into today. She was appointed to the James Webb Space Telescope deputy project scientist for the Planetary Science to continue her role through the launch in 2018. So we're really excited to talk about it today. It just recently finished completion, so everybody's we've really got a lot of questions, so we're really excited about it. So first up, welcome, Dr. Milam. How are you doing today?
I'm great. Thanks for having me.
We're excited to have you, especially because this is such a major topic. Everybody's so excited about it, and obviously you are as well. You know, you were very spirited, and in your talk at the Mars Society convention, and I think pretty much everybody is. We're all excited to see where this is going to go. But before we get into that, always first question I like to ask is, what made you fall in love with space and science when you were growing up?
So I'm from Houston, Texas. So I grew up visiting Johnson Space Center every year for school field trips and then some. My dad and my grandfather both worked for airlines, so they always had a big passion for aeronautics, and they very much encouraged me to go down there. We would look at rockets, we get to see astronauts. And from a very early age, I knew that I wanted to be an astronaut and I wanted to work for NASA. So it was either that or being a ballerina.
that is completely random, but I like it. But it's something that we tend to find in the space sciences. So many of us are interested in other things as well. It's just, I was going to be a martial arts expert, or I was going to be an astrophysicist. Where are the connections there? But yeah, it's certainly awesome. We're glad that you ended up at NASA. And so you work at the astrochemistry lab in NASA. Could you describe a little bit what astrochemistry is for those that may not have heard of it before?
So astrochemistry is what it sounds like. It is studying chemistry of space, and it varies to very much extreme. So it can be analyzing meteorites in a laboratory, seeing what kind of compounds are there, how a meteorite's been processed, where all the material came from, if there's biological materials, etc. It can also mean studying the chemistry of star-forming regions to see whether or not the chemistry is influencing how planets are formed and how the atmospheres of new planets are going to be impacted by their environments, or looking for prebiotic molecules across the galaxy. So it's very much, everything from theoretical astrophysics to actual tangible laboratory chemistry or biochemistry. So it is everything studying chemistry of space or extraterrestrial materials.
That's awesome. It was actually it's one of the new categories of astro things that I have found out about the last few years. I talked to somebody a few months ago that's an astrodynamicist, and I didn't even know what that was. Now I do, but at the time I didn't really know. So that's fantastic. So obviously this led you to NASA, and your most recent project is working on the James Webb Space Telescope, which anybody in astronomy is thrilled about because of what's coming with it. So can you tell us a little bit about the project and what makes it different from NASA's other defining telescopes like Kepler and Hubble?
So the James Webb Space Telescope is considered the predecessor of Hubble. So it is the next Hubble telescope, which is sort of a misnomer because it operates actually at slightly longer wavelengths. So it operates from the near infrared into the mid infrared, whereas Hubble was mostly UV optical and a little bit of the near infrared. So there's a tiny bit of overlap, but not too much. We do have some overlap with Spitzer Space Telescope as well, on the longer wavelengths, so in the mid infrared. JWST is exceptional because it is absolutely massive. It's 6.5 meters in diameter for just the primary mirror alone. That's about 3 times bigger than Hubble's primary mirror. So obviously there isn't a rocket that's big enough to hold such a big mirror, so we have to fold it up. So it's a fully deployable telescope. We call it an origami telescope because we have to fold everything up, including the massive sun shield that we have, which is the size of about a tennis court. So that makes it very unique. This is the first fully deployable telescope that NASA's ever launched. It's also unique in that it's going to reach wavelengths and sensitivities that no other telescope has ever been able to achieve, seeing back to the farthest reaches of the early universe. So it's definitely a unique observatory.
That's really kind of the one thing that's really been big. Everybody's been kind of talking about it, is that it's going to be able to see back to the beginning, and that's kind of the major goal, is to see back to the Big Bang. So what will that mean for astrophysical sciences if we can really go back? We have evidence for it, but what if we can see it in the formation of those first galaxies? What's it really going to mean for astrophysics overall?
So we're not going to see the Big Bang, but we will see.
Yeah. See it. That's the way we should put it.
We're sort of in the reach or the realm right between the COBE satellite and Hubble's deep fields. So you can think of it as sort of our own life cycle, right? So COBE would be, you know, the first month of a newborn's life, right? So this is the very beginning. And the Hubble deep field, so the farthest galaxies that we can see with Hubble, are sort of like in the teenage years. So we're going to be looking at the very first stars and the formation of galaxies. So this is sort of the toddler, you know, intermediate, preteens.
Preteens.
When a lot of chaos is actually happening. It'll be very exciting. And actually to be able to observe something and put measurable, an observational constraint on all of the theory that we have on how these things have formed and started and evolved is really going to have a huge impact on astrophysics.
That's really one of the incredible things about it, is just being able to see back to that time and really kind of look at how these things, we have an idea of it, but billions of years ago, how do you can, it's always going to come down to the science like this that's really going to solidify these things and also teach us things that we just never really thought about. So we are all excited to see that. And one of the big questions everybody always has is kind of, where are we going to be able to find life elsewhere? So what could possibly be discovered in regards to life supporting solar systems with James Webb that maybe we haven't seen before with other telescopes?
So James Webb has the unique capability that it can observe a lot of biosignatures and exoplanets. So the Kepler mission is out hunting for all these exoplanets. We have a number of large surveys on the ground even that are doing so. So they're giving us a target list. They're finding all the planets that they think are in the, quote, habitable zone that could possibly host a terrestrial or Earth-like environment and support liquid water, oceans, and an atmosphere, for example. So those target lists are being refined. In fact, there's another mission that's actually being launched called TESS. So this is another exoplanet mission being flown by NASA that should launch pretty close to the JWST, maybe a little bit earlier, and will also help us find even better candidates for potentially habitable exoplanets. So JWST is going to be able to go through these massive lists of all these planets, and they're going to be pinpointed on which ones we think we need to really look at. JWST is not a surveying telescope, so we're not going to go out hunting and looking for new exoplanets. We're going to go to the ones that we already know are there, and we're going to try to characterize them and see if they do have an atmosphere, whether or not that atmosphere has any chemistry, biology, any life tracers in it. And that's the unique part of JWST, is it has that sensitivity and it covers the right wavelength that we can actually start looking at these kinds of things.
That's actually really cool, because you covered a couple of questions that I wasn't able to add to this. So there's going to be people very happy with that answer. And so when will the JWST begin observing these exoplanets that Kepler has found?
Okay, so we launch in October of 2018. So far we're on schedule, so everything looks good for launch. It takes about a month to get to our orbit. We're going to be at the second Lagrange point, which is way past the other side of the moon. And never gets in between the Earth and the Sun. We can never point towards the Sun, so we're not going to be in Earth orbit. So we're going to be out at a nice safe zone called the second Lagrange point. So it takes about a month to get there and to fully unfold the telescope. Then it takes another couple of months to commission everything. So we need to turn on all the instruments, we need to make sure the telescope's focused, we need to calibrate our instruments and make sure we know how everything is working and checked out. So after that couple of months, we actually began full operations around April of 2019. And once that starts, we have a full mission. We have a requirement of 5 years of operations, but we're carrying enough fuel to support the mission for 10. So we really think it's going to last quite a while, longer than the Herschel Space Observatory, for example. So we'll have quite a lot of opportunity to actually go and look for these biotracers on exoplanets, as well as do all kinds of other science.
And that's something that NASA's really known for. Is we're going to put a telescope up for a few years, and it goes 3 times its life expectancy, and rovers, everything. It's really kind of what NASA does. It's like, we're going to do something for a few years, and then it's going to last for 20. So it's yeah, exactly. And I'm sure we're going to see some unbelievable things. And I love the fact that it's called the Origami Telescope. Sounds like somebody at NASA was just having too much fun. We have a giant telescope. It's called the Origami. That's certainly gonna stick in your mind a little bit. Obviously you're looking outside for the exoplanets, but one of the big questions that everybody's had recently, and I'll preface this by saying not the one that's been speculated about for years. That's kind of the internet rumor, but we actually think that there's a Planet 9, possibly with a very, very lengthy orbit in our solar system. Is there a possibility that will this help us discover it, or once we discover it, it's going to be able to really kind of tell us what it is? I know we think it's a gas giant, maybe like Uranus, but there hasn't really been.
As I said, it's not a surveying telescope, so we have a very small imaging field of view. Mm-hmm. So we can't look at large swaths of the sky. So that's something the JWST really doesn't do. But if we find it, we will definitely be able to observe it. And actually, we'll be able to observe it better than anything else, ground and space-based, currently available. If it is sort of like a large Neptune in the outer solar system, the wavelengths that JWST covers and the sensitivity and capability is actually going to be ideal to look at this new planet. In fact, we're planning on observations to do the Pluto as well as the new next New Horizons target, which is another Kuiper Belt object, which is really, really tiny icy rock in the extreme edges of the solar system. And JWST can actually still observe even small targets like that in the outer solar system. So even a large planet out there will just be perfect.
That's going to be great, because the speculation is that it's going to be an orbit of upwards of 20,000 years, which is out there, especially for us. And so many people think that the solar system ends at Pluto when it really kind of begins there. We've got so much even still to see in our own solar system that obviously James Webb's going to be perfect for. So since it will be so far out, as you mentioned a few moments ago, a lot of people have kind of wondered, what's the contingency plan going to be in case something goes wrong? Hubble, we can send astronauts up, and we did, or Kepler or something. If something goes wrong, it's close enough that we can. What would we be able to do in case something went wrong while it's at the Lagrange point, the second Lagrange point?
So the idea is nothing's going to go wrong.
yeah, obviously. That's the goal, and it probably won't. But yeah.
But this is why we're doing extensive amount of tests on the ground. So we're doing end-to-end optical tests. We're making sure we know how to focus and tune the mirrors. This is sort of the test that Hubble didn't have on the ground before they launched, which is one of the first issues that they found, was that they needed to fix the optics and tune sort of the telescope. But we're going to have that test. That actually happens next year at Johnson Space Center. So we'll know exactly how to fully control the mirrors and tune them to the instruments properly. With that being said, we do have deployments. The whole telescope does unfold. The origami happens. We have redundancies on every mechanism. So if one doesn't fire, and everything is controlled from the ground, if something doesn't happen, we can control it, set in our backups, and make sure the deployment actually happens. This is not a serviceable telescope. It is way too far. Astronauts cannot go to the second Lagrange point at this moment in time, and probably not within the next decade. So, and even just to send them out there, the cost efficiency is probably just so extreme that it's easier just to build a new telescope and send it out.
Well, it's good that there's some in the pipeline then, so that's helpful.
There are missions in the pipeline that will be following up JWST. So that's just, I guess we'll just have to wait for the next one if something tragic happens. But the idea is we're making sure all of our mechanisms work. We have redundancy on everything, and it will be under ground control.
That's excellent, and I think most people kind of understand that we're getting to the point now that we can't be safe with a lot of space things anymore. We're looking at deep space travel, finally getting to Mars and beyond, and to be able to do the things that James Webb is going to be able to do, is that it can only be where it's going to be. So it has to be there. And I'm certain people, but a few people were like, well, it's out there. What can you really do? But it sounds like, as usual, you guys are kind of on it. So this is really one of my favorite questions that we got from one of our readers, and it's, what is the suspected pinnacle? Like, what is the greatest achievement we can hope for if the observatory is a full success? And no pressure.
I think that depends on every person that you ask. I'm a planetary astronomer, so I think we're going to be able to discover things in planetary science that we haven't been able to achieve. We have this sort of decade of darkness happening for the outer solar system because we won't have any missions in the outer solar system for a good 10, 15 years, waiting for the next Jupiter mission or Europa mission. But even then, that's only one planet, one satellite. It's not covering the whole solar system. So this actually gives us an opportunity to sort of follow up with everything that's been done in our solar system over the last 30 plus years. As far as astrophysics and the entire mission goes, I think the most exciting thing is that we're going to learn things that we don't even know that we're going to learn. We're going to see things that we haven't thought we could see. This is exactly what happened with Hubble. I mean, they basically pointed to a blank spot in the sky, and they found thousands of new galaxies. It's just trying to expand your imagination to something that you don't even know is possible. That's one of the greatest parts about working on missions like this is try to anticipate the unknown and look forward to what the next generation scientists are going to be finding and using the observatory.
And it seems like it's everybody. We spoke with Dr. Hertz maybe about a month or so ago, and everybody is just as happy talking about it as a kid would be. Everybody that works there is obviously thrilled about it, and there's really going to be some amazing things, and we all can't wait. I know it's 2018. I can only imagine what the wait is going to be like for you guys. So finally, this is something I always like to kind of ask people is, really something that's inspired them or how they would inspire others. Being a NASA astrophysicist or working in the astrochemistry lab and being a planetary astronomer, and what you do is pretty much a dream job for myself as well as countless others. So what advice do you have for those burgeoning scientists that look up to you and want to follow in your footsteps, working somewhere like NASA or working on the James Webb Telescope?
So my story is a little unique. I'm not by trade, at least not my papers that I've worked very hard to have hanging in my office. They don't say I'm an astrophysicist. I'm actually a chemist. All of my degrees were in chemistry. And I think the biggest thing that I always tell people, especially that are working on, going into graduate school or looking for a postdoc position or even a job, it's try to think outside of the box. You're learning how to learn for a reason. And it's applying the knowledge you have into a different field, which really makes science very innovative. It's applying being a laboratory chemist to using a telescope to study chemistry in space. It's analyzing rocks here on Earth and comparing them to the geology and the surfaces of icy satellites in the outer solar system, or even Pluto, for example. So it's applying your knowledge and trying to do something new and innovative with it. That's the challenge. But once you find that niche, it's absolutely mind-boggling how revealing things can be. And it excites everybody in the community, and it opens a lot of doors and gives you a lot of opportunity.
That was a great answer. That was actually a completely original one. I'd never heard anybody say that. Funny enough, you gave an outside of the box answer to the question, which is kind of funny. So honestly, it was really been a great interview. Thank you so very much for coming on today. We greatly appreciate it. We learned some new things, and we are all watching with bated breath, and we can't wait, especially the people in the space community. This is really going to blow some minds, and we'll put a picture of the size of this thing in case you haven't seen the James Webb Space Telescope. There's a picture of a group of people that have worked on it sitting in front of it, and it is absolutely massive. So you guys, it'll kind of blow your mind. So if there's any websites or any social media that you want to give the people, and then we'll drop it below the interview as well. But if there's anything in particular you want to spotlight, please let us know.
The easiest thing to do is to go to your Google and type in JWST. But our primary website is jwst.nasa.gov. And you'll find links to all of our social media. learn more about the project, the status, see all kinds of great pictures. We have our own YouTube video or link and account. You're welcome to upload anything and use it. Everything that we have here at NASA is for public use. If you want to follow me, I'm on Twitter. It's SN Milam, M-I-L-A-M. And JWST also has a Twitter account. I think it's JW or Webb Telescope.
Yeah, I think you guys changed it recently. You had one and moved it.
Yeah. They're also on Facebook. But as I said, if you go to our main webpage on NASA, you'll find links to all of those.
Awesome. And thank you again. And thank you so much to our people that submitted questions, like our readers and our friends at Science in the Wild and Ripple Aerospace. And those guys, you guys really came up with some great questions and allowed me to look a little smarter than I am. So thank you so much once again to Dr. Milam. And we can't wait to see what you guys are going to do in the future.
Absolutely. Thanks so much.